Hi, this video is on permutations. So permutations, when you calculate permutations, you calculate the number of different arrangements of items in which the order is going to matter. We often deal with things like arranging items in specific order or assigning various jobs or titles to people. And you're not always going, well, please don't expect the word order to be present there. And let's take a look. So example 1. In how many ways can 5 bands be arranged to perform at the rock festival? Well, so what do we have? It's actually very easy to analyze, even though we didn't even talk about how to do that. We have 5 slots open for 5 bands, right? So when you select that lineup, how many bands can go in the first slot? You can have 5. After that, you have 4 slots left, 4 bands. The second slot can be filled with any one of the 4 bands, and any one of the 3, any one of the 2, and one remaining band is going to be in the last position here, right? So you multiply all that. This is actually going to be 5 factorial, if you're familiar with that notation, and 5 factorial is 120. Okay. Example 2, same 5 bands, but one band must close the show. They're very popular and they have to be the headliner and they have to be very last one. So how is it going to change the problem? Well, we still have 5 slots open, right? But there is one specific band that must close, so it has to go there. How many bands do we have left after that? 4, correct? So for any one of the 4 can fill this slot. Any one of the remaining 3 can fill this slot, any one of the remaining 2, any one of the remaining 1. This is going to give us 24. So there are 24 different ways this can be done. See how drastically that changed? Alright, moving on. So Led Zeppelin tribute band wants to play a 10-song set. If they want to open with Immigrant Song and close with Stairway to Heaven, how many ways can they arrange their set list? We can use exactly the same logic. So we have 10 slots here for 10 songs, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. So there is one song that must close the show, which is Stairway to Heaven, and one song that must open the show, which is Immigrant Song. And that's going to leave us with 8 more songs to choose from, right? And if we use the same logic we just used before, any one of 8 songs can go here, any one of the remaining 7, 6, 5, 4, 3, times 2, times 1. Okay. Which essentially is going to be 8 factorial, right? And you can calculate that, and that's going to be pretty easy math, and 8 factorial is 540. So there are 540 different arrangements you can have here. Michael wants to spend his day of watching his favorite gangster movie. So what do we have? He wants to watch The Untouchables, the Godfather trilogy, Casino, Goodfellas, The Bronx Tale, and Donnie Brasco. He wants to start by watching Godfather trilogy in order, finish by watching Goodfellas. First of all, how many movies do we have total? So Untouchable is 1, let's tally them. Godfather trilogy, that's 3 more. Casino, Goodfellas, Bronx Tale, and Donnie Brasco. Right? So that's, let's check again. 3, 4, 5, 6, 7, 8. So we have a total of 8 movies. 1, 2, 3, 4, 5, 6, 7, 8. We have to start with the Godfather trilogy in order, which means we know for sure what's going to go in the first slot. The Godfather 1, Godfather 2, Godfather 3. He wants to finish by watching Goodfellas, so that's going to be 1. What is left? Well, we are left with 4 movies times 4 times 3 times 2 times 1. All that is going to give us 24 different orders that he can do it in. So we have something called a permutation formula. That formula allows you to compute permutations of different objects, which we're going to take a look at how it's applied. This is the formula. So this is N, P, R. So you're selecting R items out of N. This number is always bigger. And you can either use the formula or you can also do it on the calculator. And what we do is we are going to take a look how it's done. So how do we do this with using the formula? So this is going to be 9 factorial divided by 9 minus 4 factorial, which is going to be 9 factorial divided by 5 factorial. And all you need to do is calculate that. And that's going to be essentially 6 times 7 times 8 times 9. Right, 6 times 7 times 8 times 9, which is going to be 3024. That's what this value is. Okay. 7p6, which is going to be 7 factorial divided by 7 minus 6 factorial, which is going to be 7 factorial divided by 1 factorial, which is 7 factorial, and 7 factorial is going to be, let me check this math really quick, 7 factorial is 5040. So this equals 5040. Alright, now let's see how we are actually going to do it. Due to schedule changes, only 4 out of 5 bands from problem 1 can perform at the festival. So how many different ways can the promoters select and arrange 4 bands to perform? Keywords here, select and arrange. So we're selecting 4 and arranging them in orders. So what we're going to do here is we have 5 bands to choose from, and we're selecting 4 and arranging them. Okay. You can actually do it on the calculator too. You have a graphing calculator. Most of them are equipped with this. So what you do is, in my case, I'm going to type in 5. Then I'm going to hit the math button. I'm going to go all the way here to where it says PRB. And I'm going to select option number 2. And then I'm going to press 4. And that's going to give me 120. So there's 120 different ways to do that. John bought 8 new books, however he has only room for 5 books on the shelf. How many ways can he arrange 5 books on the shelf? 8 to choose from, 5 books to choose. Again, let me show it one more time how we do it. So we're going to type in 8. This is TI-84 that I'm using. Don't look at the Inspire, this is actually TI-84. Math, I'm going to go to PRB, select option 2. And I'm going to choose 5. 6,720 different ways. Okay. Alright, let's continue. More examples. The board of the directors of a corporation has 6 members, and how many ways can they elect the president, secretary, and treasurer? So this problem does not have any order involved. However, we have 3 different positions. So not only are we picking 3 members to fill those positions, but there are also different ways how these positions can be assigned. So this is a permutation problem. So we have 6p3 because we're selecting 3 members. So we do our process and we're going to get 120 different ways this can be done. 10 students participate in the math competition, and how many ways can the top 3 prizes be awarded? So not only are we talking about 3 top students, but we're also going to award prizes differently, which means we have permutations. This problem is 10p3. So we do 10p3, and that's going to give us 720 different ways how this can be done. Okay. Let's continue. A radio DJ received 15 song requests, but only has enough time to play 4 of them. And how many ways can he select and arrange songs to be played? So, obviously we're selecting them and arranging them in specific order. So there's going to be 15p4, 15p4 is going to be 32,760 different ways how this can be done. Imagine that. Now we're going to talk about arranging items. There's a common question when you try to figure out how many different ways you can arrange letters in the particular word. So this is a situation when we're talking about this 6-letter word active. Please understand, we're not talking about meaningful words, we're just talking about shuffling letters any which way we can and see how many different ways this can be done. So, since there is all the letters are unique here, this is simply going to be 6 factorial, which is 6 times 4, 5 times 4 times 3 times 1, right? And that is going to be 720. So it's very easy when the letters are unique. You're just talking about arranging those items that are given to you, and that's it. But what happens when you have repetition? So when you have arrangements with repeating items, let's take a look at the word account. So the word account has 1, 2, 3, 4, 5, 6, 7 letters. So if all the letters were unique, you would have written 7 factorial and you would have evaluated that. But we have a repeating letter C. Because of that repetition, you have 2 letters like that. We are going to divide this by 2 factorial. We simply count how many times this letter repeats. Okay, so what we're going to do now is we're going to take 7 factorial divided by 2 factorial, and that's going to give us 2,520. Okay. And how many ways can you arrange letters in the word Seattle? So what's different here? The word Seattle has 7 letters also, right? So 7 factorial. If they were all unique, but they're not, we have 2 E's and 2 T's. So what does that mean? That means that we're going to be dividing by 2 factorial times 2 factorial again. 2 factorial for each repetition here that we have. If you're going to use your calculator, please make sure you put the bottom expression in parentheses so it properly calculates that. So how is that going to change? Well, let's see. It's going to give us 1,260. So you can see that there are 2 problems here that in each case you have 7 letters, but in example 13 there's only 1 repetition of 2 letters. In example 14 you have 2 repetitions of 2 letters, and it significantly changes the number of arrangements. I have a few more examples. In how many ways can you arrange the letters in the word Hollywood? Well, that's even more challenging now because we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. If all the letters were unique, we would have done 9 factorial, but what do we have here? We have 1, 2, 3 letters O, and we also have 2 L's. So for each repetition that we have, we're going to put that number factorial. So for 3 O's, we're going to put 3 factorial. For 2 L's, we're going to put 2 factorial. And if we're dividing with the calculator, we need to make sure we wrap it in parentheses. So we're going to go ahead and type it in the calculator. So that's going to be dividing by 3 factorial, and that's going to give you a total of 30,240 different ways. And our last example here is going to be Anita has 1 red brick, 3 black bricks, and 2 brown bricks. She wants to lay them horizontally to make a border in front of her flower bed. How many different ways can she arrange them? It's actually a problem that's very similar to what we just did with arranging letters. It's the same exact thing. We have items that we need to lay out in order, and we're trying to figure out. So how many bricks do we have total? We have 6 factorial. If you had 6 different color bricks, then your answer would have been 6 factorial, but because we have repetition, we're going to be dividing by it. So 6 factorial, here we're going to divide by 3 factorial for black bricks, times 2 factorial, which is going to give us, which is going to take 2 brown bricks into consideration, right? So what we do is we divide 6 factorial. 6 factorial, and we're going to divide it by 3 factorial times 2 factorial, which is actually 6 times 2, which is 12, so we can just divide by 12, and the answer is going to be 60 different ways. Okay, this is how it's done.